Another example, assume no initial energy stored in the circuit at t equals to 0 and that Is is 10 U of t amperes. So A, find VO of S using Thevenin's theorem. B, apply the initial and final value theorems to find VO of 0 plus and VO of infinity. And lastly, determine VO of t. So first, let's apply Thevenin's theorem by finding the equivalent circuit across these terminals. Let's label this as terminal A and B. Converting the circuit to frequency domain, we have 10 over S for dependent source, which is Ix, and we have 2S. This is our VTH. Now since this is open, our Ix is equivalent to 0. So meaning this dependent voltage source, if this is 0, this is just good as a short circuit. So we have by KVL or by Ohm's law, our VTH is equivalent to 5 times this current source. So we have 50 for S. Now solving for RTH, we can solve for the short circuit current. In this case, the short circuit current is just equivalent to Ix. Applying KVL at this mesh, we have Ix, KVL at Ix, we have 5 times Ix minus 10 over S minus 2Ix plus 2S Ix equal to 0. So solving for Ix, we have Ix times 2S plus 3 equal to 50 over S, or Ix equivalent to 50 over S times 2S plus 3. Now ZTH is equivalent to VTH over Ix equal to 2S plus 3. Now we can draw our equivalent circuit. This is VTH series with ZTH, and we can connect our 5 ohm resistor, and we can solve for VO. So VO of S by VDT, VO equivalent to 5 over 5 plus 2S plus 3 times 50 over S, or this is equivalent to 125 over S times S plus 4. We have for letter A. Now for letter B, apply the initial and final value theorems to find VO of 0 plus and VO of infinity. So for the initial value, VO of 0 is equivalent to the limit of S, VO of S, as S approaches to infinity. Our equation becomes 125 over S plus 4. Now if this denominator approaches to infinity, this will become 0. So initial value is 0. Now for the final value, we have VO of infinity equivalent to the limit of S, VO of S, as S approaches to 0. We have limit of 125 over S plus 4. So this is equivalent to 31.25 volts. Now for letter C, determine VO of T. So VO of T. So first, let's use partial fraction to determine VO of T. Equivalent to A over S plus V over S plus 4. So we can write this as solving for A and B. AS plus 4 plus BS. So if S is equal to 0, A is 31.25. If S is equal to negative 4, B is negative 31.5. Our VO of S equal to 31.25 over S minus 31.25 over S plus 4. Now converting this into time domain, we have 31.25 times E times quantity 1 minus e to the negative 4 t u of t volts. Now finding the initial and final value using this time domain expression, we have, if we have v of 0, VO of 0, just we have 31.25 minus e to the 0 is 1, so we have 31.25 equal to 0, which is the same with this one. If we have v of infinity, so if you look at this term right here, e to the negative 4t, if t approaches to infinity, or if t is infinity, this expression becomes 0. So we have 31.25 minus 0, we have 31.25 volts. It's the same to this one.